videos. This is sets video 2, and we've been introducing sets. We've been talking about what a set is, so we're going to talk through that again briefly and then look at some of these weird symbols that we come across in sets. We're going to look at these 3 symbols here and what they stand for. We're going to talk about what it means to define a set by a rule. We're going to talk about equal sets and subsets. So just a really quick video here about those things. So the first thing to say is that a set is a collection of items that are similar. A set is a collection of items that have something in common, that are similar, that have something in common. Okay, set is a collection of items that have something in common. So for instance, A is the set of even numbers between 10 and 20 inclusive. So if I was to list the set A, it would be A. Remember, I'd use curly brackets and then I'd write down all the even numbers between 10 and 20, including 10 and 20. Okay, there's set A. Remember, we write each number once and we put a comma between them and we use these curly brackets. Now, those items that are in the set are called elements. So the items in a set, or the members of a set, are called elements. And the way we write this word element, we say is an element of. We have this symbol that looks like a euro symbol. This is kind of E. So if I wanted to say that 10 was in set A, I would say 10 is an element of A. Or I could say 12 is an element of A. I could say 18 is an element of A. If I want to say that something is not an element of a set, then I do that symbol, but with a line through it. So is not an element of. Okay, so something like 15 is not an element of A. 36 is not an element of A, and so on. Okay. Set B, let's just list what set B was. It was the set of odd numbers between 20 and 30. So set B would be 21, 23, 25, 27, 29. Obviously, it's a different set to set A. They have different elements in them. So if a set has different elements in it, then they are not equal to each other. We'll talk in a moment about what an equal set looks like. Okay, set C is the set of pupils in high school who are 3 meters tall. Now, I don't know about you, but I don't know any pupils in high school who are 3 meters tall. So set C would be empty, would be an empty set. It has no elements. And the way we write that is we say C equals, that's empty set. Or in other words, we can say C equals the null set. Okay, and that symbol there means null set. Null means null and void, means not at all, there's nothing in it. So that's the null set. So a set that has no elements is a null set or an empty set. Okay, so that's covered element, the brackets, empty set, null set, and not an element of. Okay, how do we define these sets by rule? So there's a special way of writing it. We would say B equals, and then I do brackets. Now this is the weird bit. I do X and a line and X. And in English, that would be X such that X. In real English that we use every day, that would be X is an element of the set if. X is an element of the set if. So X such that X. So this is the set, remember, of odd numbers between 20 and 30. So set B equals the set of elements, X, if they are even odd numbers between 20 and 30. X such that X is an odd number between 20 and 30. Okay? So you see how we do that? X such that X, that's the bit that doesn't change. Every time we do a set, that's the bit that doesn't change. But what it means is it's an X such that X is an element of the set if it's an odd number between 20 and 30. So set A would be, curly brackets, X such that X is an even number, remember, between even number between 10 and 20 inclusive. So the elements, what that's saying is, translation, the elements of set A are even numbers between 10 and 20. Okay? Now, what else do we need to look at? We need to look at three particular number sets that we've talked about before, briefly. N, if you remember, is the set of natural numbers, and these are the numbers that you learnt about when you were in national school, the counting numbers. So they're positive whole numbers. So that's 1, 2, 3, 4, 5, and so on. Then you've got Z, which weirdly means integers. I think it's to do with some German word. I think somebody can look that up if you like. And that's positive and negative whole numbers. So so something like, say, let's start back here at -3, -2, -1, 0, 1, 2, 3, but going on infinitely in both directions. Okay? And then we've got R, which is rational numbers, which are any numbers that can be written as a fraction. That can be written as a fraction. Okay, so rational numbers. So for instance, 2/3, 3/4, 7/10, and so on. Okay, so N is natural numbers, which is positive whole numbers. Z is integers, which is positive and negative whole numbers. And R is rational numbers. And that's denoted actually not by R, sorry. R is real numbers. Q is the letter for rational numbers. So Q is the set of rational numbers. Okay, we're nearly there. Last couple of things. I've got to talk about equal sets and subsets. So if I list three sets, let's call them X, which is A, B, C, D. Let's call them Y, which is B, D, C, A. And let's call them Z, which is A, E, I, O, U. Okay? If you look at set X and set Y, they have the same elements, but they're in a different order. It doesn't matter what order they're in, they still have the same elements. So equal sets have the same elements. So set X is equal to set Y there because they have the same elements. Set Z is not equal to set X, and set Z is not equal to set Y because they don't have the same elements. So equal sets have the same elements. Okay? So equal sets have the same elements. And the last thing we're looking at here is what's called subsets. So say I said to you we had set M, which is the set of pupils of the high school. Okay? You might have lots of smaller groups that belong in there. You might have the set of all hockey players in high school. You might have the set of all Form 1 pupils in the high school. You might have the set of all pupils aged 17 in high school. Okay? Each of these smaller groups are subsets of set M. Okay? And so a subset is a set which is usually smaller and whose elements are found, in this case, in set M. Okay? So the elements of these sets, the hockey players in high school, the Form 1 pupils in high school, the pupils age 17 in high school, are all smaller sets made out of this big set, and that's what a subset is. Now if we take a number example, or let's just take a letter example. So say, let's say P is the set X such that X is a letter of the word maths. Okay, hopefully you know what that means is that set P is the set with elements M, A, T, H, and S. The subsets of P are any set made out of those elements. So you might have set with just M in it. You might have a set with just A in it, or just T, or just H, or just S. Or you might have a set that has M, A, or maybe a set that has T, S, or maybe a set that has A, T, H. Any set that is formed out of the set maths is a subset of set P. Okay, any set that contains elements and from set P and only from set P is a subset. Okay, I hope that helps. Bye.